Now there are two techniques for finding inverse Z transform. Inverse Z transform. There are two techniques for finding inverse Z transform. They are, first one, partial fraction expansion method, PFE method. PFE method means partial fraction expansion method. Second method is long division. Second method is long division. Both the methods are there in the curriculum and I will be teaching them. Directly I will teach you problems how to do them using partial fraction expansion method to begin with. So first I take a problem. Given x of z is equal to z divided by 3z square minus 4z plus 1. Find x of n for the ROCs indicated. For the ROCs indicated. What are they? Three ROCs are given. First one, mod z greater than 1. Second one, mod z less than 1 by 3. And third one, mod z greater than 1 by 3 less than 1. So I am going to solve this. Solution. First step is use PFE method. And even in the examination sometimes you will not specify any method, but you have to assume it as PFE method. PFE method means partial fraction expansion method. Step 1 is convert x of z divided by z into partial fractions. Convert x of z by z into partial fractions. In majority of the functions x of z, z will be available in the numerator. What you have to do? Convert x of z divided by z into partial fractions. Before that, we have to factorize this 3z square minus 4z plus 1. So what I will do is, I will write x of z is equal to z. I take 3 common and I will write this as z square minus 4 by 3 into z plus 1 by 3. We have to factorize this. For factorizing this, what I will do is, I am going to say note, I will equate this term to 0. Z square minus 4 by 3 into z plus 1 by 3 is equal to 0. If you get the roots, the roots are z equal to 1 and z equal to 1 by 3. These are the roots. Using calculator, solve this quadratic equation to get these roots. Then what I will say, this I call equation 1. Then equation 1 can be written as, z minus 1 into z minus 1 by 3 equal to 0. This is the way we can factorize this quadratic function. This in turn implies x of, so I will now rewrite x of z. What I will do, I will write x of z is equal to x of z by z I will write, because I have to convert x of z by z into partial fractions. 1 over 3 into z minus 1 into z minus 1 by 3. This I will write as k1 by z minus 1 plus k2 by z minus 1 by 3. Where k1 and k2 are the constants associated with partial fraction expansion. Let us now proceed to find k1 and k2. So k1 into z minus 1 by 3 plus k2 into z minus 1 equals 1 by 3. There are two unknowns here, k1 and k2. Therefore, to find k1 and k2, take two arbitrary values of z and then solve two resulting simultaneous equations. Here it is very easy. First one, put z equal to 1. This implies, put z equal to 1. This implies k1 into 1 minus 1 by 3 is equal to 1 by 3. This implies K1 is equal to half. Then I'll say put Z equal to 1 by 3. Then this will become 0. What we get? K2 into 1 by 3 minus 1 is equal to 1 by 3. This implies K2 is equal to minus half. You can use any method what you know to find the values of K1 and K2. Substituting the values of K1 and K2 in equation 2, what we get? Substituting the values of K1 and K2 in equation 1. What we get? X of Z divided by Z is equal to K1 is half into 1 over Z minus 1 minus K2 is minus half into 1 over Z minus 1 by 3. Now I cross multiply throughout by Z. Second step, to find x of n. Now you multiply both sides by z or cross multiply with z. So what you get? X of z is equal to half into z divided by z minus 1 minus half into z divided by z minus 1 by 3. This I call equation 2. Till here, you do not worry about ROC. I will take the first ROC. What is the first ROC given? First ROC is mod Z. First ROC is mod Z greater than 1. I will plot the poles and mark the ROC. Z plane is a complex plane having real axis real Z, imaginary axis Z times imaginary Z. The entire Z plane is assumed to be inside this rectangle. The entire Z plane is assumed to be inside this rectangle. Mod Z greater than 1 means I draw a circle of radius equal to 1. Equation of this circle is mod Z equal to 1. ROC is mod Z greater than 1. That means ROC is the region outside this circle. ROC is the region outside this circle. The hatched area represents the ROC. ROC is what? Mod Z greater than 1. Next I will plot the poles of x of z. What are the poles of x of z? Roots of the denominator polynomial are called poles. They are z equal to 1 and z equal to 1 by 3. I told in the properties, poles form the boundaries of ROC. Therefore, you see the circle is passing through this pole. Very, very important. Now, both the poles, what is the ROC? Mod Z greater than 1. Both the poles are interior to the ROC. See, poles will be either interior to the ROC or they will be exterior to the ROC. No poles can lie within the hatched region. That is the property which I have already given earlier. So now I am going to say both the poles are interior to the ROC. Both the poles are interior to the ROC, and hence they will give positive time sequence terms. I'm going to write in the brackets for your reference. A to the power n into u of n has z transform z divided by z minus a. That means inverse z transform of this is what? For this term, what is a? A is 1. For this term, what is a? A is 1 by 3. So what we get? Take inverse z transform of this. X of n is equal to half into a is 1. So it is what you get? 1 to the power n into u of n. Here what is a? 1 by 3 minus half into 1 by 3 to the power n into u of n. 1 to the power n is 1, so you get half into u of n minus half into 1 by 3 to the power n into u of n. This is the answer for the ROC mod z greater than 1. Next, I will consider the next ROC. Second ROC, mod z less than 1 by 3. First draw the pole zero diagram, indicate the ROC, then find poles whether they are interior to the ROC or exterior to the ROC. J times Z plane is a complex plane having real axis real Z, imaginary axis J times imaginary Z. The entire Z plane is assumed to be inside this rectangle. I'll draw a circle of radius equal to 1 by 3. Equation of the circle is mod Z less than 1 by 3. ROC is mod Z less than 1 by 3 means ROC is the interior region of this circle. What I am hatching is the ROC. ROC is mod Z less than 1 by 3. These are the two poles, one is at 1 by 3, the other pole is at 1. Now you see both the poles are exterior to the ROC and hence they will give negative time sequence terms. I am going to write here both the poles are exterior to the ROC. Both the poles are exterior to the ROC and hence they will give negative time sequence terms. Negative time sequence terms. What I mean is, what is Z transform of minus a to the power n into u of minus n minus 1? It is nothing but Z divided by Z minus a. That means inverse of this will be found using this formula. Inverse of this also will be used using this formula. Hence, what is x of n? Find inverse of this. Hence, x of n equals half. See, there is what is inverse of this? Minus half into 1 to the power n into u of minus n minus 1. There is a minus sign here already, therefore it is plus half into 1 by 3 to the power n into u of minus n minus 1. So this is nothing but minus half into u of minus n minus 1 plus half into 1 by 3 to the power n u of minus n minus 1. So depending on the ROC, same function x of z will give different answers for x of n. Therefore, ROC plays a very important role in finding inverse Z transforms. This aspect was made pretty clear in the beginning class. Last ROC is mod Z greater than 1 by 3 less than 1. Again, we will mark the poles and draw the ROC. Z plane is a complex plane having real axis real Z, imaginary axis J times imaginary Z. The entire Z plane is supposed to be encompassed inside this rectangle. I will draw two concentric circles. Having radii 1 by 3 and 1. Mod Z lies between 1 by 3 and 1 means the annular region between these two concentric circles is the ROC. The annular region between these two concentric circles is the ROC. One pole is at 1 by 3, the other pole is at 1. The pole at Z equal to 1 by 3 is interior to the ROC. Therefore, it will give positive time sequence. The pole at Z equal to 1 is exterior to the ROC. and hence will give negative time sequence term. I am going to make that comment. The pole at z equal to 1 by 3 is interior to the ROC, and hence will give a positive time sequence term. That means this what will be the inverse of the quantity inside this bracket? 1 by 3 to the power n into u of n. The pole at z equal to 1 is exterior to the ROC. And hence will give a negative time sequence term. Positive time sequence term means a to the power n into u of n. Negative time sequence term means minus a to the power n into u of minus n minus 1. Therefore, what is x of n? X of n is equal to, this will give minus half into minus 1 to the power n u of minus n minus 1. Minus 1 to the power n is 1, minus 1 to the power n. 1 to the power n is 1 only. This will give positive time sequence term minus half into 1 by 3 to the power n into u of n. I repeat, positive time sequence term means in this context it is a to the power n into u of n. A equal to what? 1 by 3. Negative time sequence term means it is minus a to the power n into u of minus n minus 1. What is a here? 1. Correct? And this minus sign is reflected over here. 1 to the power n is 1. So we can write this as minus half into u of minus n minus 1 minus half into 1 by 3 to the power n into u of n. So for the same function x of z, there are 3 possible answers for x of n depending upon the ROC given. I hope you people have understood this problem. So I'll go to the next one.